Mindsetters. Hi guys. Welcome to your winter school lesson for geography. I am Lini and that is Michelle.
Hi, Looney.
How are you doing?
Well, thanks. How are you?
I'm good, thanks. So what are we doing for the Mindsetters today?
We are going to look at some past questions from the Climatology section of the exemplar paper and one or two things from the February-March paper as well.
Alright, cool. Mindsetters, I hope you guys are very excited for your show and that you're sitting in front of your TVs and you're going to download all the show notes and you're going to go through the questions as Michelle is working through them as well. Just a quick reminder, facebook.com/learnextra is our Facebook page. That's where you get all your notes and all the information that we post about competitions and stuff, you get them on our Facebook page. Twitter, our handle is @learnextra, and as you know, we have a winter school competition going on. So all we need you guys to do is go to our Facebook page, and then from there you go to a link. There's a link on our Facebook page which takes you to an entry form. There you enter your favorite team. So there's Argentina, USA, Belgium, and Switzerland. The team you think will win and the team you support, you choose from those teams, and then after that you go to our Facebook page. There's also links to your favorite teams that takes you to a graphic where you get all your friends to like that picture. Okay, right now USA is at 485 likes, Switzerland is at 233 likes, Argentina is at 795 likes, and Team Belgium is at 285 likes. What's your favorite team, Michelle?
I think the USA or
USA.
Argentina. I personally like USA. I like the way they play, very structured.
Alright.
But I'm a Germany supporter, so I can't really say.
Okay. Well, in the first show, I was USA, but now because Argentina is leading, I think I'm going to be Team Argentina for now. So make sure, guys, you get all your friends to like those posts if you like a certain team. And at 3:30, the entries close, and then winners of the favorite team we'll go through an entry lucky draw where we pick a winner, and then on Friday, you'll stand a chance to win an Intel tablet. Michelle.
All right, thank you very much, Looney. All right, Mindsetters, today we're going to, as I said, go through a couple of past papers. And perhaps you're resting a bit after your June exams, perhaps you're a bit worried about how you did in those exams. So right now is a very good time to try and consolidate some of that material so that you are well prepared for your prelims, which are actually just around the corner. So let's have a look firstly at all the items we're going to be covering today. In this lesson, we're going to revise high and low pressure systems. Those are the questions that I've set for you to do. We are going to examine the structure and effects of tropical cyclones. We're also going to discuss the influences of various pressure systems over South Africa and how they influence our climate. We're going to look at and study synoptic weather maps as well as the stations that go along with them. And also we're going to revise urban and valley climates. Let's get into those questions. Before we do that, however, let's have a look at the challenge question for today. You have to explain why the letters Q, U, X, Y, and Z have fairly recently been excluded from the possible lists of tropical cyclone names. Now, I'm not going to help you answer that questions just yet, that'll come at the end, but just to explain a little bit to help you along there, when they name tropical cyclones, you should already know by now that they start at the beginning of the alphabet, so at the letter A, at the start of each season, so it's spring or summer, depending on the region that you're in. And they'll actually have lists going all the way from A right down to S, all the way to T, and they'll actually have those lists planned ahead of time. So next year's names for the tropical cyclones that are supposedly going to affect Mozambique and Madagascar have already been planned. They've already been thought of. Okay. Interesting fact as well is that in certain cases like Hurricane Katrina, they'll actually omit those names from future lists because of the devastation and the heartache and the trauma that they caused. So let's see if you can answer that by the end of the show. Let's move on to those questions. First one, question 1. They are all coming from the exemplar of 2014. You have to look at the following questions based on the weather station model below. Let's have a look at the model itself before we get into those questions. You have to be able to both draw and describe the weather conditions at various weather stations. So the first thing that you're going to look for is this circle here, okay, which illustrates where the weather station model is. It's been fully colored in. All right? So a fully colored in circle means that the cloud cover is going to be overcast. We always write that in terms of eighths. Okay? Try not to write it in terms of halves or quarters, always in eighths. Okay? So it's 8 of 8, it's overcast, completely cloudy. Next thing that you're going to look at is this line here, which illustrates the weather or the wind direction. Right? Now try and imagine that that line is pointing towards that cloud cover circle. Okay? It's telling you where the wind is coming from, and it's going towards the direction of that arrow there. So if we have our wind direction line pointing in this direction, it's actually coming from the northeast. Okay? A northeasterly wind. Usually, they're going to draw little feathers at the end or along that line as well. A longer line illustrates 10 knots. If they were to draw shorter lines, those each represent 5 knots. So it's going to be a 5-knot wind. Okay? It's a very, that'll be a 10-knot wind. I do apologize. 10-knot wind. If it was a smaller one like that, it would be a 5-knot wind. 3 of our conditions are listed already. Let's have a look at the numbers on the side. Let's have a look at the symbols that are illustrated in between those numbers as well. We have a look at this top number, 24. That illustrates or tells us what the air temperature is going to be. Always write it out as air temperature. Okay? When you're writing it out, always put the correct symbol, degrees Celsius. If you have a look at the number below, it says 21 there. Okay? That 21 does not refer to minimum temperature. It refers to dew point temperature. And in this case, it's going to be 21 degrees Celsius. Always write degrees Celsius. You're going to lose the marks if you don't put the correct symbols or units with those numbers. Lastly, in between, if we have a look here, we've got a little symbol which is shown by a little colored in dots. You must know your symbols very well. We were taught them in grade 10 and 11. And in this case, the precipitation that we expect is going to be rain. So I encourage you to go and learn all those symbols off by heart so that you can easily identify them. When you're writing it out, make sure that you use the appropriate units. Make sure that you give at least 6 items in that list. You're also required to know how to draw the model from a list of information, so make sure that you can replicate that in terms of a weather station model as well. Now that we've deciphered a couple of those factors, let's have a look at those questions. First one, it asks you to write down the air temperature at the weather station. So as we've already deciphered, that was 24. Can't just leave it like that. Put in degrees Celsius, and you'll get your mark there. Very simple, very easy. Second question. From which direction is the wind blowing? It's asking you where it's coming from. Okay? So we said that it came from the northeast. It's going towards the southwest, but it's coming from the northeast direction. Preferably write it out in full in your exam, so northeast. Okay. Then, what is the wind speed in knots? Okay, I know they've given you the unit there, but always write your unit as well. In this case, it was 10 knots. Note the spelling as well. We have a look at the next question. Question 1.4. Does the cloud cover indicate overcast or clear skies? Okay. Remember, we had a look at that weather station model Nana, and we saw that it had been colored in full. Okay. So that would represent 8 over 8. 8 over 8 is the same as overcast, which means there's no sun. You can't see any sun. There's just clouds covering the sky. Okay. If it was clear, they would just draw an open circle without coloring anything in. And in that case, you could say that it's clear or that the cloud cover is 0/8 or 0/8. Just before we move on to the next question, I want to point something out to you as well. Notice that the difference between your dew point temperature and your air temperature is very small. So when that difference is small, it means that your humidity is going to be higher, therefore you're going to have more condensation and greater cloud cover. So that's also a clue or a hint. Look at the difference between the air temperature as well as the dew point temperature, and it should point to whether or not you're going to have overcast conditions or clear conditions. If that difference was big, it would mean that your skies would be a little bit clearer. Let's have a look at the next one. It asked you to name the precipitation shown on the weather station model. You have to know your symbols very well yet again, and in this particular case, the symbol indicated that there's going to be rain, and that matches with our overcast conditions. That matches with the fact that we have a very small difference between our air temperature and our dew point temperature, which means there's going to be greater humidity. Clouds are going to form quite close to ground level as well. Let's have a look at 1.6. Write down the dew point temperature at the weather station. We had a look at that a couple of minutes ago, so in this case, just write it down, 21 degrees Celsius. I can't tell you how many times I mark papers and they don't put their units in. Guys, you're going to lose marks, so please put in degrees Celsius. Always put in the correct units. Question 1.7. Is the probability of rain high or low at this weather station? Okay, there's a couple of things that we need to examine to answer that question. So remember, we had overcast skies. Okay, when we have lots of clouds in the sky, lots of condensation, lots of water droplets in the atmosphere, the likelihood of rain is higher. When we have a very small difference between the dew point temperature as well as the air temperature, it also means that there's high humidity levels, which means there's more water vapor in the atmosphere, there's more likelihood of condensation taking place, and therefore more rain will probably occur. So in this case, because we've got that overcast sky, because we've got that very small difference between the air temperature as well as the dew point temperature, it means we're probably going to have a little bit of rain on that day. All we have to write to answer that question is going to be a high probability of rain. Sometimes they're going to ask you for a reason, but this case, 1 mark per answer, so we just write the word high. Let's have a look at the next diagram before we take a break. Question 2. It asks you to study the information and satellite image of the tropical cyclone Haruna in Figure 2 and to answer the questions that follow. Let's just have a look at the write-up there. Right? Tropical cyclone, okay, Haruna. It developed in the Mozambique Channel, that's off the east coast of southern Africa, that's in the southern hemisphere, on the 18th of February in 2013. It reached a peak wind speed of 150 kilometers per hour. It weakened significantly when it reached land, where a previous system had already flooded the land. When Haruna arrived, 7,402 houses were totally destroyed. Rice and maize crops were damaged, and that's probably a lot of their staple diet. Their economy comes from producing crops. A large amount of people were killed, 127 were injured, and there was also an outbreak of diseases, probably like cholera and typhoid, after the tropical cyclone dissipated. Dissipated means it died out. It died out, or it dissipated, on the 24th of February 2013. So it lasted a good 7 or so days there. We have a look at the diagram quickly. All right. They give you a little diagram and they show you a center point there. A, we're going to have to name that. You should know that the center of a tropical cyclone, when it reaches its mature stage, that's called the eye of the storm. Very calm, very clear conditions there. Because this particular tropical cyclone is in the southern hemisphere, I want you to notice the cloud pattern. Notice that it swirls inwards, clockwise. In a low pressure cell, like a tropical cyclone, the air converges in the center of the cell, all right? And because it's in the southern hemisphere, it also travels clockwise. In the northern hemisphere, that would be reversed, anti-clockwise. It would still converge in the center, but it would travel in a more anti-clockwise direction, okay? So we know we've got a low pressure, it's got an eye in the middle. In this case, it's traveling in a clockwise direction, and the winds are converging in the center of that cell. So you must know your primary characteristics of tropical cyclones and their features, and later on when we get to the questions, we're going to look at the effects and possible mitigative strategies as well to overcome those effects. I think it's time for a break before we tackle those questions, Leni.
All right. Mindsetters, let's take a very quick break, but don't go anywhere. We'll see you straight after this. Welcome back, Mindsetters, from that break. I hope you guys are enjoying the geography show. Michelle.
Thank you very much, Leni. Let's go back into tropical cyclones. I'll refresh your memories in case you've forgotten a few things. We'll have a look at those questions as well as some others that are coming your way. Let's have a look quickly just to recap. Remember we said that that center feature indicated by A was the eye. The eye is actually associated with very calm, almost like an eerie sort of calm in the midst of a storm. And the reason that that happens is because the pressure is so low at the surface that air is sucked into, where it converges, it's sucked into the system, even from the higher atmosphere. So air is actually drawn downwards as well as laterally into the system. And that creates those calm, very clear conditions in the middle of the eye. We said it was converging in a clockwise manner. In the northern hemisphere, that would be anti-clockwise. It would still have the eye in the northern hemisphere. It would still have converging winds. Okay. You also need to know a couple of things about the requirements for tropical cyclones to form. So in order for them to form, they form over oceans. And these oceans can only occur between the latitudes of about 5 degrees and about 30 degrees north and south. And the reason for that is it needs very warm water vapor, which comes off that warm sea surface in order to form. So that warm air will rise, that water vapor will be evaporated, and it will condense, releasing what they call latent heat, which drives the whole tropical cyclone as well. They also need Coriolis force to form in order for that deflection of winds to occur. And they need the tropical easterlies, because the tropical easterlies are what actually move or propagate the tropical cyclone in its direction. So in our case, they will be coming from the east with the tropical easterlies, and they will be moving towards the southwest. And the Mozambique Channel, Mozambique, Madagascar fall within that 5 to 30 degree latitude bracket. So they often get affected by tropical cyclones. Let's have a look at the questions. All right, question 2. 2.1, you have to name the center of the tropical cyclone or hurricane. Tropical cyclone, however, where we are in the Mozambique Channel, on the satellite image, okay, that's called the eye. Remember that that eye forms because air is drawn into the very low pressure at the surface of the earth, forming those calm, clear conditions. Question 2.2. State, only for 1 mark, the direction in which the clouds are turning or rotating around the center of the tropical cyclone. We deduced that because it's in the southern hemisphere, that it would be rotating clockwise. So in the southern hemisphere, clockwise. That's the answer that they're looking for. Just be aware that in the northern hemisphere, this will be slightly different. It'll be anti-clockwise. They tend to give examples from the southern hemisphere, but just don't be caught out unawares if they do give you an example from the northern hemisphere, hurricanes and typhoons. 2.3. What was the lifespan, so the time of its existence, of the tropical cyclone Haruna? Okay, let's go back to that excerpt so we can see the dates over which it formed. Okay, There we go. It formed or started to form on the 18th of February 2013, and it dissipated on the 24th of February 2013. So in order to answer that question, we need to consider and include the day it starts and the day that it ended. Okay? So they said from the 18th of Feb to the 24th of February. Make sure that you include the 18th, and if you count that, it gets you to 7 days. Okay, so it was about a week that this tropical cyclone wreaked havoc along those coastal areas. Right, question 2.4. How many tropical cyclones, including Haruna, have Mozambique or has Mozambique already experienced for the season? Remember, I said that they start at each season with the letter A and they work through the alphabet. So Haruna is the 8th letter of the alphabet. It asks you to include Haruna. Okay? So we know that there have been 8 tropical cyclones. Sometimes, and they often like to ask this question, they'll ask you, how do you know that or why? Okay? So you can say that tropical cyclones are named according to the alphabet, alphabetically, starting at A each season. And as I said before, they actually have predetermined lists of those tropical cyclones for many years ahead, so that those names are planned already. Question 2.5. Give one reason to explain why tropical cyclone Haruna weakened when it moved over Madagascar. Okay, let's just discuss that for a minute. Remember that I said that tropical cyclones need very warm sea surface temperatures in order to form. They need that water to evaporate and become water vapor and condense, because that process of condensation releases what we call latent heat. And this is the energy. It's called hidden heat sometimes as well. This is the energy that actually drives the tropical cyclone. So if we don't have an ocean with sea surface temperatures of a minimum of about 27 degrees Celsius, we're not going to have a tropical cyclone forming, or we're not going to be able to sustain a tropical cyclone. The sea surface itself also offers less friction, so the tropical cyclone can move along at great speeds without slowing down. Now, as soon as it hits land, firstly, there's no moisture, okay? There's no warm sea surface to release that energy, that latent energy that sustains the tropical cyclone. And also the land surface, it's not a smooth surface. It's got undulations, or it's got hills and mountains. It actually slows the tropical cyclone down because of those barriers. That land surface creates friction, which actually slows down the tropical cyclone as well. Okay, so you only needed one reason, but either of those is fine. Let's write it down. Okay, so firstly, the land surface causes friction, and that slows the tropical cyclone down. Okay, and because we're over a land mass, Madagascar, okay, there's no ocean, okay, or warm sea surface temperatures or supply of water vapor that is required to sustain that tropical cyclone. Only one reason though, so as long as you've explained it, you'll get your 2 marks. Let's have a look at the last question for this particular one. It asks you to evaluate why, or explain why the impact of a tropical cyclone is more severe in a country like Mozambique than in more developed countries. Let's have a look at a couple of those stats that were given to us in the example. It tells you that firstly, hundreds of people died, many houses were destroyed, 7,000 houses. Okay, that's a lot. There's a lot of people displaced there, probably because they're not built properly. Okay, they're in a third world country. All their crops were destroyed as well, and that's their sustenance. That's a lot of them farm subsistence style farming methods, and so that keeps them going. That's what they feed their families with. Lots of people were injured as well, probably because of all the debris, and there was also lots of diseases. Okay, and that usually happens when you have sewage which leaks into our water supply, or those lines or pipes burst, and so a lot of diseases like cholera and typhoid get into the drinking water. So there's quite a few things that we can talk about. Alright, so where it says evaluate, you basically need to explain why they're not able to cope with that tropical cyclone and its effects. Okay, so first of all, we're in a developing country. And that means quite a few things. Firstly, lots of people died and were injured because there was probably no warning or limited warning. No warning, no broadcast of the impending disaster via television, radio, cell phones even. Okay? They probably also don't have response teams, emergency teams. And those people are usually trained to deal with casualties, to deal with the wreckage and the damage that is caused. Okay? They probably also have poor structures, poor housing. Okay? They're built with materials that are not weather resistant. And not weather resistant. And so that means they're probably more prone to falling over. Okay? In a developing country, they also don't have resources. They don't have money, they don't have resources to cope with these disasters. They also probably don't have things like emergency supplies. And what I mean by that is they don't store food, or blankets, or shelters even. In addition to that, the people of Madagascar and these less developed countries, they probably don't even know about some of the dangers. They don't know the dangers, the hazards that they're going to face of a tropical cyclone. They're also not educated. And therefore they don't know what to do. They don't know to evacuate. So there's quite a few options for you guys there. Remember, this is your essay question, so in the past they've asked us to, or asked you to write it in a paragraph format. So don't just write key phrases, write them out in sentences. Actually explain that you know what it means to be less developed, to not have resources. Know that you know it will be able to explain the fact that because people are not educated, that they don't know where to evacuate, or they don't know what to do in case of a disaster. Before our next break, let's have a look at the next diagram, and then we'll cut to a short break again. Right, question 3. It asks you to study the synoptic weather map. You're always going to get one of these, and to answer the questions that follow. So it's quite a busy looking map. Let's have a look at its various components. Firstly, they've labeled a couple of cells which are all quite incremental to our weather over South Africa. So cell A is our high pressure cell. Okay. They have specific names, and if it's over South Africa, like this one is, that actually it has a name. It's called the continental high. We have another high pressure system that they want us to label later on. Cell B, Okay, it's also a high pressure cell. It's in the Atlantic Ocean, so it also has a name. It's called the South Atlantic high pressure. We also have the South Indian high pressure, which should be over here. If I could draw that in there. And then cell C, that's a low pressure cell. Notice its characteristic features. It's got a cold front and a warm front there. You must know that those are called mid-latitude cyclones. And mid-latitude cyclones, more often than not, is quite a big chunk of your paper, so you need to know them very well. All right, a couple of other features that you need to look at as well. They'll often show you lines that look a little bit like contour lines on a map, but they represent something different to altitude. So these lines that are drawn here, those are called isobars, all right? They go up in fours, all right? Isobars are lines joining places of equal pressure. We measure that pressure in hectopascals, so that would be 1,008 hectopascals. It has an isobaric interval, as I mentioned, of 4. That's if the lines are solid, like you've shown here. If they're drawn dotted, that means it has an isobaric interval of 2 hectopascals. You'll notice that there's quite a few weather stations drawn all over our country, and you often have to look at them as well to determine the effects before and after of things like a mid-latitude cyclone. They're also going to ask you questions like, is it winter or is it summer? And often these days they don't give you the date to give you a bit of a hint there. So you've got to look at things like the air temperature. Are we experiencing cold fronts? Do we have clear skies over most of the country? Is it raining in the southwestern Cape? Are the temperatures fairly low? So those are key things that we're going to examine in a while. Over to you, Leni, for a quick break.
All right. Mindsetters, I see a lot of you are still asking me how to enter the winter school competition. So I'll take it through with you very slowly. Firstly, there's a link on our Facebook page, the first link, which has a /learn in capital letters. If you click on that link, you get a chance to pick your favorite team. Once you've done that, you go back to our Facebook page. On Facebook, we have links that take you straight to the favorite team that you've chosen on the Curio page. Right? So if the link has /Argentina, you click on that link if you've chosen Argentina, and then you get all your friends to like that picture on Facebook. So if you like Argentina, you get all your friends to like Argentina, like. And then if Argentina has the most likes by 3/2, everyone who's liked Argentina will go through a lucky draw. We'll pick a name out of that, and then on Friday, all the people that we've chosen throughout the week, on Friday we have a final draw. All those people are going to be in that draw, and then we'll choose one winner from that, and then that person will win an Intel tablet. I hope you guys understand how the competition works. Just by the way, your team is very behind USA. My team is ahead, Argentina. So guys, if you like USA, make sure you get all your friends. You get all your friends to like that. And with all of that said, let's take a very quick break, and we'll see you straight after this. Welcome back, guys, from that break. I hope you guys are enjoying this geography lesson for winter school, grade 12. Michelle.
Thank you, Leni. All right, before we left for the break, we were looking at a synoptic weather map, and we were looking at some of the features of that synoptic weather map. Let's go through a couple of definitions, a few more anyway, before we tackle those questions. Sometimes I ask you, what is a synoptic weather map? A synopsis just means a summary of the weather conditions usually over one particular day over South Africa at all its different weather stations. We went through what isobars were. There are lines joining places of equal air pressure. Remember, we measure air pressure in the unit of hectopascal. Sometimes you can also say millibars, so hectopascal and millibars are the same thing. If they ever ask you what is the actual instrument that measures air pressure, that will be called a barometer. Okay, so just some extra stuff for you to really prepare you for those exams. We looked at some of the cells as well. So we said that this particular cell, cell A, was called the continental high pressure system. Usually dominates South Africa in winter, giving us our nice clear conditions over the high veld. Cell B was the South Atlantic high pressure system. Note that its isobars are ridging, they're elongating almost. Okay? And usually that happens just after or before even certain cold fronts will pass. It actually ridges in behind that cold front. Okay? Cell C, this one here, that's called a mid-latitude cyclone. So all of those are weather systems or pressure cells that will affect our weather. If we have a look at the mid-latitude cyclone, it has different features. So this one here, that's your cold front. Notice it's got triangles or shark's teeth to indicate that it's a cold front. Usually you'll see that on your weather maps if you're watching the news channel. A warm front is also indicated there. That's semicircles that are colored in, right? And those two are features of the system that is called a mid-latitude cyclone. One or two other things as well here. There's a little low pressure system off the west coast. That is called a coastal low. It's also known as a traveling disturbance, and it will migrate all along the coast all the way to the eastern coast, and it usually is associated with bergwind conditions. Let's have a look at those questions quickly. You had to firstly identify, so just write a name for the three pressure systems labeled A, B, and C respectively. So A, that was called the continental high pressure. Don't just call it a high pressure, you're not going to get your marks. Continental high pressure. Or, if you really want to be fancy, you can say continental anticyclone. High pressure and anticyclone are the same thing. Cell B, okay, is called the South Atlantic high pressure or anticyclone. Just take note that if you don't write South or you don't write Atlantic, they mark it wrong. Cell C is called a mid-latitude cyclone. That's the most common word for it. Sometimes they're also called temperate cyclones. So you can use either or, but just be able to use them interchangeably in your exams. Let's have a look at the next one, question 3.2. Explain, so you have to write a sentence, not just give me a phrase, why high pressure cell A stops rainfall over the interior of the country during the winter months. Okay, so cell A, remember that was our continental high pressure. Okay, there it is there. Let me get to it quickly. It's actually part of the subtropical high pressure belt. Now you need to know your characteristics of your high pressures in order to understand this question as well. Remember that when we're dealing with high pressure systems, that your air is sinking, okay, from the top of the atmosphere towards the surface. So the air is usually quite cool. So cold air will sink. As it sinks, it heats up because the air gets compressed. So we say that it heats up adiabatically. The bottom of that cell, or the bottom part where the air is sinking, is sometimes called an inversion layer, because what is happening there is as we increase with altitude, the temperature is actually getting warmer. Okay, and it's that continental high, that inversion layer together, that prevents any moisture from rising or evaporating off the surface or from the ocean, and it prevents clouds from forming, which is why over the high fault we've been experiencing, besides for a thunderstorm the other day associated with the cold fronts, we've been experiencing lovely, fine, sunny conditions. It's because at high pressure, because the air is sinking, it's not allowing for any condensation or evaporation to take place. You also need to know that that inversion layer, okay, at the bottom of that high pressure cell where the temperature is actually increasing with altitude, it's also blocking any moisture that comes off the ocean, especially from the South Indian side. And none of that warm, moist air is allowed to rise towards the interior, towards the plateau, and condense and form rain clouds. Let me aid my discussion here with a quick little diagram. Okay. Forgive my drawing skills, but we're going to try here. So imagine that this is the interior. There's a plateau. There's the escarpments. there's the coastline, and there's the ocean. Okay, so there's our sea. Right? So in winter, our high pressure is dominating the interior, so that that cold air, it warms as it sinks, but it sinks towards the surface of the earth. With that, we have what we call an inversion layer. So that's the bottom extent of that high pressure cell. Okay? There's our inversion layer. That means that the temperature is increasing with altitude. So what's happening is any moisture that comes off of the sea and evaporates, tries to get moisture inland, it's blocked. It's physically blocked by that inversion layer. So this would be cell A here, the continental high pressure. It's pressing down, it's pushing down on the interior, on the plateau. That inversion layer here is preventing any moisture coming in from the sea. Okay? That inversion layer usually lies below the plateau or along the escarpment during our winter months. During summer, this will be reversed. So the inversion layer would actually lift, allowing that warm, moist air to come in from the sea. Okay, so if we're going to explain why the high pressure of cell A limits the rainfall, I'm just going to write a few keywords here to aid my discussion with the diagram here. Okay, so cool air is sinking. Just block that off there. So that doesn't allow for any evaporation, doesn't allow for any condensation, right? The inversion layer also blocks any moisture which comes off the ocean. You only needed usually only one reason. In this case, they wanted two. So you have to say the cold air is sinking in that high pressure cell, as I'm showing in the diagram. That's preventing any uplift of moisture, it's preventing any condensation. And in addition to that, that inversion layer also blocks moisture which comes off the ocean. Okay, quite an important concept. They often like to ask you a diagram like this. So go back to your textbooks and make sure that you can sketch out a diagram like I've shown you there. Let's have a look at the next question. It asks you, what evidence is on the synoptic weather map that suggests the high pressure cell B is ridging? Let's have a look at that weather map once more. So if we have a look here, where cell B is, I want you to notice again that those isobars are actually elongated or extending outwards away from the center of the cell. So because we see an extension, an elongation of those isobars, it illustrates what we call a ridge. Let's write an answer down quickly. So our isobars at cell B, they're extending themselves outwards or elongating outwards. And that illustrates a ridge. Ridges are associated with high pressure cells. If we're talking about a low pressure cell or a cyclone and the isobars extend outwards, we actually call that a trough. So troughs are where we have an extension of low pressure isobars. Ridges are associated in this case with high pressure cells. Let's have a look at question 3.4. You had to evaluate, so explain, the negative impact of the cyclone labeled C on the economy of South Africa. Read your question carefully. They're asking about the economy. Okay. So firstly, we know that cell C was a mid-latitude cyclone. And you're going to have to know something about its formation and what sort of weather patterns it brings over South Africa to be able to talk about this. It's quite a difficult, challenging question. So remember, when mid-latitude cyclones form, okay, they're associated with a warm front and a cold front. Now, with the cold front, we usually have a lot of cumulonimbus clouds, a lot of thunderstorm activity because of the way warm air is forced almost vertically into the atmosphere. With the warm front, we get more nimbostratus gentle, soft, soaking rain type of clouds forming. And when they ask for the economic impacts, they usually want to know what happens when a cold front has passed over. So firstly, when we have a cold front and its thunderstorm activity that's associated with it passing over the country, sometimes we get flooding, especially if a cut-off low develops. So flooding will damage things like crops. Okay, and if our crops, like our maize crops, our winter wheat supplies even are damaged or they're flooded, it means that we don't have any food supply. Now we're going to have to increase food prices, we're going to have to import from other countries. In addition to that, it damages infrastructure, telephone poles, electricity wires, and all that has to be replaced. And in addition to that, our transport networks or our infrastructure also get damaged. So that means that the transport of produce like maize and wheat is also hampered. So it has a lot of knock-on effects to our economy. So let's jot a few things down before our next break. All right. So firstly, your crops will get damaged. And that could reduce our food supply as well as our exports. In addition to that, our food prices will increase because we don't have enough, so we have to make up for our losses. In some cases, in some dire cases, we have to import food at a higher cost. In addition to that, infrastructure will get damaged. And so we can't transport our produce. If you wanted to add a few other things in, you could also say that telephone poles, electricity supply could get interrupted as well. And all of these things have to be replaced, and that costs a lot of money. You could also add in even that property can get damaged by hail, by lightning. Cars get damaged by hail, for example. So that all costs time, effort, and money, in addition to losing some of your crops, which could mean our economy suffers at quite a great expense because of that. Before we move on to our next little break, let's have a very quick look at the next diagram. All right, question 4. Valley climates. You always get questions on valley climates, and they're actually very easy. Okay, with a valley climate, first thing I want you to look at and identify is whether this is happening at night or during the day. So this particular scenario, we've got wind that is blowing down slope. It's called a downslope wind or a mountain wind or Katabatic flow, which occurs mainly at night. Okay? And that's happening because the cold air, there's no more sunlight, so the air is really cold, it's dense, it's heavy, so it sinks to the bottom of the valley, and it will form often what we call frost pockets on the valley floor. The warmer air gets displaced above that, and it creates what we call an inversion layer, okay, where the temperatures are actually increasing with increasing altitude. And this little factory is actually at a very bad place here because that inversion layer is kind of trapping all those particulates, all that pollution, quite close to the valley floor, quite close to where people are going to be living. So it's going to create all sorts of problem. Okay, so before we move on to our next questions, I think it's time for a break, Leni.
All right. Mindsetters, let's take a very quick break. I hope you're still reminding your friends to like your team. You've got a few more minutes because entries close at 3:30. With that said, let's take a very quick break and I'll see you straight after this. Welcome back, Mindsetters. I hope you guys are enjoying the show. Michelle.
Thank you, Leni. All right, guys, we were looking at valley climates. We've got this set of questions, and then we've got some more on urban climates questions to do, and we're almost there, so stick with me. Let's get through these questions. Let's get some nice consolidatory learning in before those big prelims that are looming up. Let's have a look at the diagram once more just to refresh your memories. We said that this situation is occurring at night, and the way you tell that is by looking at the direction of airflow. So if it's flowing down the valley, it means that cold air, cooler air will sink, creating downslope mountain breezes or katabatic airflow. Because that cold air collects at the bottom of the valley, it forms what we call a frost pocket, because sometimes those temperatures are at 0 degrees or less, and so frost will condensate onto the valley floor. Our slightly warmer air that's inside the valley will be displaced upwards, and it will create what we call an inversion layer. And because we have this factory blowing all sorts of smoke into the atmosphere, that inversion layer will trap all of those gases quite close to the valley floor, and it will affect quite a lot of the residents who live there. It'll be cold, and there'll be a lot of smog, very uncomfortable conditions. Let's have a look at a few of those questions. Question 4.1. Name, for 1 mark, the wind labeled A. There's a couple of options. Most correct is to say it's called a downslope wind or a mountain wind. They do also in this paper accept katabatic flow. So katabatic flow, which means that air will blow down the length of a valley. And that happens because of a very cold temperatures at night, which causes that air to be denser and so move downhill. So in our next question, we need to explain that. Explain why wind A occurs at night. Okay, so at night there's no more sun. Okay, so at night time, the air is going to be cool, and therefore it's going to be dense, or heavier, and denser air will sink downslope, and it will collect on that valley floor. Okay, so first of all, you needed to say that the air is going to be cool, because of the cold night temperatures, and therefore, because it's denser and heavier, it's going to sink downslope. Okay, quite an easy explanation for 4 marks there. Question 4.3. A temperature inversion has formed at B. With reference to figure 4, assess the impact that this is likely to have on the health of the people living in the valley. Okay, so if we have a look at that diagram once more. Remember I said that all of this pollution from that factory will get trapped underneath that inversion layer. And that pollution, you can inhale, you can cough a lot from it, cause lung diseases. Some people who suffer from asthma don't cope very well. It can irritate your eyes, and can irritate your skin. So it's not a good place to live. Okay. So with the inversion layer, you need to say that the pollution is trapped. And so it has a greater concentration. Okay, it's trapped close to the valley floor. In addition to that, it can cause lung disorders or lung disease. So people who already battle with asthma and those sorts of conditions, they will struggle quite a lot. It can also irritate your eyes, all that soot in the atmosphere. It irritates the eyes. And it also irritates the skin even. So it's not a pleasant situation. So 2 of those things for 2 marks each. We have a look at the next question. Okay. Explain 2 reasons or give 2 reasons why area C is not suitable for planting of all types of crops. If you have a look there, remember I said that at the valley floor, okay, so this is where C is, that's where this frost pocket develops. That's where the temperatures are at 0 degrees or less. We'll have a lot of frost developing there, and a lot of plants, a lot of trees can't withstand that. So first of all, if you write something down here, the temperatures are often below freezing. And a lot of crops can't withstand that. And many crops can't withstand frost. There's something called black frost. And what happens there is that the tree sap or the sap of the plants will actually freeze and it kills the plant from the inside out. So it's not a very wise place to plant your millies. Let's have a look at the next question there. Question 5. Study figure 5, which shows the microclimates, in this case the urban climate of a city. A couple of things that you've got to recognize here first. Okay? Notice that they're giving you temperatures on the y-axis here. So those are your temps in degrees Celsius. Don't forget your units. Okay? And then on the x-axis, they're showing you various zones of a city. They're also showing you what they call an urban heat island. So notice of your city, that's where all your buildings are going to be, all your traffic's going to be, the temperatures are much higher. And that we call a heat dome or an urban heat island, which is the higher temperatures over the city compared to the cooler rural and suburban areas. Fairly simple question. Couple of theory questions are going to come out as well, but there's nothing too complicated. Question 5.1. Which areas in the city experience the highest as well as the lowest temperatures respectively? Okay? So if we have a look at our highest temperatures, let's read them off the graph. Okay? At the peak of our city, we're sitting at about, let's say, 33.5 degrees, okay? And in our rural urban fringe here, we're sitting at, let's say, roughly about 29.2 degrees, okay? So let's write out, not the values, but just where we have higher and lower temperatures. So the highest temperatures, okay, will be over the CBD, or you can say downtown or the city center. And the lowest temperatures, those are on the rural urban fringe. Right, next question. 5.2. You have to define the term urban heat island. It's only for 1 mark, so you must get the whole definition right. Okay? So a heat island is where our city center or our CBD has higher temperatures surrounded by cooler suburban and rural areas. As long as you get the concept right, you'll get your mark. Learn your definitions, learn your concepts, that's half your paper done. Question 5.3. State one difference between an urban heat island and a pollution dome. Let's go back to our diagram quickly for this one. An urban heat island occurs usually during the day especially because hotter temperatures, which are coming off the surface of the earth, cause air to rise and expand. So this physical dome actually has quite a large vertical extent. at night, let's use a different color here, the air is cooler. So our dome, as such, will be more concentrated over a smaller area because the temperatures are cooler, the air is not rising quite as far. And because we've got a lot of industry in this area here, okay, you'll find that all of that pollution, because the air is sinking, it's cooler, it will get trapped within a smaller area, very concentrated, much like we looked at in our valley climate. So the difference here, our pollution dome has a very small extent, and it happens usually at night. Okay? And then our urban heat island, usually during the day we'll see its greatest extent because all that hot air is rising and so dispersing any pollution. Let's write a quick answer down. Okay, so for our urban heat island, okay, it has a higher extent. Okay, so it's a higher vertical extent. And the reason for that is during the day, hot air rises. And in so doing, it actually disperses more pollution. On the other side of the coin, okay, our pollution dome it's usually got a lower extent, lower vertical extent. And this is happening because at night, your cool air sinks and it actually traps more pollution. So next time you're driving around in the city, or you're with your parents driving around in the city, and it's early in the morning, I want you guys to notice that there'll actually be a physical layer of smog, which is kind of sitting over the city. And the reason that that's happening is because the air is still cold. The sun hasn't had time to heat the ground up and thus have hot air currents rising upwards. So all of that pollution kind of collects in a very small area, which makes it sort of smoggy, dusty appearance over the city. During the day, you won't really notice it. Why? Because the air has had time to heat up. The sun has been heating the ground, so your air will rise in vertical air currents, and so that pollution will be less concentrated because the extent of that heat island is slightly higher. A couple more questions to get through. Let's get through them, guys. Question 5.4. Give one reason why a pollution dome forms. Could be twofold here. Okay? You could say that industry in the city, it releases, or they release, pollution. And that pollution often gets trapped due to that cool sinking air. Or you can even say it gets trapped by the inversion layer. Because of that dominant high pressure cell over our interior. 2 marks. Okay, question 5.5. Discuss 2 factors in a sentence, evidence that cause cities to record higher temperatures than the surrounding rural areas. This is a possible essay question as well. So let's go through a few of those things quickly. So firstly, our buildings have a greater surface area, so they absorb more heat. Okay. There's also more pollution. There's no trees or no vegetation, which help to absorb heat or helps to absorb some of the carbon dioxide that could get trapped in that pollution layer. Okay. Also, the surfaces are dark, so they absorb more heat as well. And the last question, I'm not going to have time to write down, just to go through it quickly. If you were in an urban area, or you were an urban planner, okay, let's go through the question. I'll do the answer with you after the break. Describe how you would sustainably decrease the impact of urban heat islands. We're not going to have time to do this one just yet, but after the break, we'll quickly run through those answers. Leni, back to you.
All right, mindset is let's take a very quick break. Looks like Argentina has won for today. So if you chose Argentina and you know that you ask your friends to like Argentina's picture, make sure you tune in, because after the break we'll do the lucky draw, and then that name will be sent into the draw for Friday. So with that said, let's take a very quick break and we'll see you straight after this. Welcome back, Mindsetters, from that break. Like I promised before the break, we are now going to do the lucky draw for Friday's entry. So for today, Argentina won. So if you chose Argentina, you must just stay glued to your screen and hope that your name comes out of the box. Michelle,
Yes.
if you can just come and do the honors. Don't look. Why are you looking?
I'm not looking. Cue drum roll.
Okay. And the winner is?
Refilwe Siboko.
Okay.
So, well done.
You are entered into, congratulations, Refilwe Siboko. You are entered into the lucky draw for Friday to stand a chance to win that Intel tablet. Okay. Sorry to the other guys who picked USA, Switzerland, and Belgium. Sorry, guys. Argentina won. And Refilwe Siboko is the winner. Congratulations to you. Michelle.
All right, Mindsetters, on to that last question for urban heat islands. Let's get through that, then we can get to our challenge question as well. We have a look there again. If we were an urban planner, what are we going to do to sustainably decrease the impact of urban heat islands? So there's a number of things that we could do. Okay. So firstly, we could use reflective or light-colored materials, or light surfaces that reflect more heat so that they don't absorb so much heat, creating that urban heat island effect. We could use more efficient public transport. And so reduce the amount of greenhouse gases in the atmosphere, which help to trap heat. We could plant more trees. They absorb carbon dioxide, they provide shade. We could also plant rooftop gardens, which have the same effect. And in addition to that, lastly, we could implement more water features. The reason that they say that water features are so important is because when water evaporates into a water vapor, it requires heat in order to perform that process. So latent energy or heat is used to evaporate that water, and so reduces the amount of heat left in your atmosphere. So all of those things could be used to sustainably reduce the urban heat island effect. Looney, is it time for the challenge question yet?
Yes, you can do the
All
challenge
right.
question.
Let's have a look. Once again, let's go through the question. They were asked, or you were asked, to explain why the letters Q, U, X, Y, and Z have fairly recently been excluded from the possible lists of tropical cyclone names. Okay, remember I said to you that they plan these names years and years in advance. Okay, and this is actually not part of your syllabus, but it's actually a fairly simple question if you think logically about it. Remember that letters like A, B, C, D, there's a lot of names that start with each of those letters. But when you start looking at Q, U, X, Y, after a few years you're going to start running out of names. So simply because there aren't enough names to be assigned to those letters, they've actually chosen to exclude them from all possible lists of future hurricanes and tropical cyclones. Okay, I hope some of you got those right. Leni, are there any questions that we need to go through?
Yes, we have a question here from Banele Charlie, and he's asking if he'll be wrong for question 1.4.
All
If he'll
right.
be wrong if he said 4/4 instead of 8/8.
Okay. Remember, we were looking at the question right in the beginning, which showed us a weather station model, and it showed that the circle was completely colored in. And I said that the answer was 8/8 or overcast. Now, they usually prefer you to work in terms of eighths. Okay, so 4/4 is still overcast. It's not technically wrong, but when we're recording it on a weather map, it should always be in terms of eighths. So even if it's a half, but 4/8. If it's a quarter, but 2/8. The only ones where you can just write a word instead of actually putting it in terms of eighths would be for 0/8, which means the skies are clear, so you can write clear. Or if the cloud cover is 8/8, you can put overcast as well. So please make sure that you're always putting it in terms of eighths, please. I hope that helped.
All right, and then another one from Tejo Smith. He is asking, or she's asking, I'm not sure. I want to know if I can write coastal high pressure instead of continental high pressure.
Okay. You can't write coastal high pressure, all right? Because that high pressure system dominates the interior of our country, which is the continental part. Okay, it's not by a coastal region at all. So you have to write continental high pressure. The high pressures that are more or less towards the coastlines, those have their own names. South Atlantic high pressure, South Indian high pressure. So continental high pressure is the only thing that they're going to accept. Boho. I hope that helps you. Any other questions?
That is all we have.
Right. All right, just a few things before we wrap the show up, guys. Remember that those prelims are coming up. So those of you that are watching the show today in your holidays, I commend you on sticking with your studies. I commend you on wanting to consolidate some of your work. Remember, keep those summaries going. You've still probably got a whole of economic geography to go. So this stuff that I've been going through today, it should be more of a refresher course. Okay, you should already know all of these concepts now. And if you noticed, and if you've watched previous shows, you'll notice that the questions are usually the same. Okay, just applied to a different context. So know your terminology from grade 11 climatology, because high pressures and low pressures, they are an integral part of this section. Know your mid-latitude cyclones very well as well. There weren't too many questions on them in these particular papers, but they always put a fairly large section in your final matric paper. Know with mid-latitude cyclones, know the effects, know how to draw your cross sections, know your various stages as well of your mid-latitude cyclones. They're usually a slightly bigger part actually of your paper. Tropical cyclones, they usually give you an excerpt from the news or a diagram for you to look at, and you always have to label things like the eye. You have to know their structure. Sometimes they're going to give you a cross section. Know the economic, the social, environmental impacts and how to deal with those as well. Valley urban climates, know the basics. The questions will never ever change. You'll see the same essay questions also come up time and time again. With your South African weather, it's also really important that you guys know how to interpret your synoptic charts, as well as to identify seasons and all the different impacts that the various weather systems have on our country in both winter and summer. Thank you very much for listening. I really hope that you've gained something from this lesson today. Luni?
All right, thank you so much, Michelle, for the
My
lesson.
pleasure.
Mindsetters, thank you so much for tuning in. From me, until next time when I see you. More winter school sessions coming up, guys, the whole of the week, so make sure you are tuned in. Up next is History with Meg, so make sure you are tuned in. But from me, until next time, goodbye, guys.